So if you're watching this video, chances are you probably already know what the three main Pythagorean trig identities are. But not all the time do people really learn about and dive into why these equations are what they are or where they even come from. So that's what we're going to be talking about in this video. So get you a pencil, grab your notebook, and let's get it.
I got sauce, baby. I got sauce. I got sauce, baby. I got sauce.
What is going on, YouTube? I'm Almond with the sauce, and welcome back to another Precal tutorial. In this one right here, we're going to be basically proving and deriving some Pythagorean identities. These identities that we're going to go over right here basically are going to allow us to simplify and solve some trigonometric equations. And they also allow us to prove even more identities once we understand these three. Literally, if you understand Pythagorean theorem and SOHCAHTOA, that's basically what these equations are derived from. All right. And so the name Pythagorean kind of hints at Pythagorean theorem, which applies only to right triangles. So in our unit circle, I can make any right triangle to start my proof. So, okay, so we can call this, if I want to call this A and I want to call this B, I could call this C, but because it's a unit circle, I know my radius is 1, so I'm just going to put that. And so, using Pythagorean theorem, we would have just a squared plus b squared equals, again, c squared, but in this case, just 1. Also think about this. If I put theta right here, think about SOHCAHTOA. A really acts as the opposite side, B acts as a adjacent side, and then my 1 is my hypotenuse. If you think about your trig functions that you already know, you know that sine is equal to opposite over hypotenuse. You know that cosine is equal to adjacent over hypotenuse. But remember, our hypotenuse is 1, and anything divided by 1 is itself. So if I'm thinking about the sine of theta, that's a divided by 1, which is really just a, So a and sine of theta are literally equivalent. Actually, I'm going to write that down. Sine of theta is equal to a because a is the opposite side and my hypotenuse is 1. And dividing by 1, a divided by 1 is still a. So for my other side, b, again, this is the adjacent side, and adjacent comes into play whenever you're talking about the cosine. So I could say the cosine of theta, it is equal to b over 1, but again, dividing by 1 doesn't do anything. So b over 1 just simplifies to b. And you can probably already see where this identity comes from. If I just substitute a for sine of theta and b for cosine of theta, then I will get sine. Now, I know a lot of people want to say like sine of theta squared, but the way we write it is just sine squared theta plus cosine squared theta equals 1. All right, and that's actually my first trig identity right there. Sine squared theta plus cosine squared theta equals 1. Sine and cosine, they kind of go together a little bit, but those are only 2 out of the 6 trig functions. So we actually want to use this equation to make 2 more equations to involve the other 4 trig functions. If I want to include tangent and secant, which they kind of go together, tangent lines and secant lines. If you can recall, tangent is nothing more than sine over cosine. And I can actually form that, if I have this sine divided by the cosine, and because the top one's squared, I'm going to let the bottom one be squared. So this right here is tangent squared of theta. But because I divided this by cosine squared theta, I got to divide every other term by cosine squared theta as well. So it'll end up looking like this. All right, divide everything by cosine squared of theta. All right, and so y'all know sine squared theta over cosine squared theta is just tangent squared theta. And then you also know anything divided by itself, that's just 1. And then equals, now again, you kind of got to know your reciprocal identities. 1 over cosine squared theta, that is the same thing as secant squared theta. And so as you can see, we have another equation that can relate tangent and secant. We have one that relates tangent and secant, and then we can actually come up with a third equation that's going to relate cotangent and cosecant together. But in order for me to do that, I'm going to start with my original equation and then manipulate that. Again, recalling those reciprocal identities, cosine over sine is cotangent. You can use that to come up with another equation. Again, anything divided by itself is 1. plus cosine squared over sine squared, that is cotangent squared. And then 1 over sine squared, that's another one of those reciprocal identities where it's just equal to cosecant squared. And those are it right there. Those are the 3 Pythagorean trig identities. Usually what they're used for, like I said, is basically simplifying trig expressions, solving equations, verifying equations. And then, like I said, there's some more identities down the road that stem from these 3 equations right here. And I know that was kind of a quick one, but that's gonna wrap up the video. I'm gonna leave y'all with 2 examples to try on your own, where we're gonna be simplifying expressions using these 3 identities. Try them out on your own. Once you think you got them, head over to my IG. I'm gonna drop the link in the description below. And with that being said, y'all, if y'all like the video, make sure you hit that thumbs up for me. Don't forget to subscribe if you're new. And with that being said, I'll catch y'all in the next one. Again, cosine over sine, that's wait, what is that? Cosine squared over sine squared, that's what is, why